Welcome to Nobility Learning Center. Today, I will present you about oxidation and reduction reaction. There are two kinds of chemical reactions in chemistry. One is oxidation-reduction reaction, or we call redox reaction, and the second is non-redox reaction. In oxidation-reduction reaction, there is transfer of electrons from one substance to another, but in non-redox reaction, there is no transfer of electrons. Instead, there is exchange of ions between substances. Here, there are what learning goals. Students at the end of this lesson will be able to define the terms oxidation and reduction reaction, determine the oxidation number of an element in a given formula, describe the oxidizing and reducing agents, identify the reactants oxidized and reduced, and distinguish between redox and non-redox reaction. Okay, let's start about oxidation and reduction reaction. There are different kinds of oxidation reactions that we have got in every day of our life. The first one is, the most common one is rusting. Rusting is oxidation reduction reaction. Rust forms when the oxygen in the air reacted with iron. In this process, electrons are transferred from iron to oxygen. The second example is the green patina on the start of the Liberty is due to the oxidation of copper metal as it forms a green solid, copper 1 oxide, in which this is the chemical reaction on the start of Liberty. Copper solid form loses 2 electrons, and it forms copper plus. Okay, it is oxidation, because the oxidation state of oxygen is changed from 0 to copper to plus. The oxidation state of any neutral atom is 0. Okay, and oxygen gains 2 electrons, and it forms O2 minus. The oxidation state of oxygen is changed from 0 to -2. This one is reduction, and the overall reaction is oxidation reduction reaction, or we call redox reaction. Let's define what does oxidation and reduction mean. The broadest definitions are: oxidation means loss of electrons, reduction means gain of electrons. Here in this picture, there is a chemical reaction in which there is transfer of electrons from one atom to another atom. Okay, this one lost electron, and this one gains electron. The process of gaining electron is reduction. The process of losing electron is oxidation. Here, there are multiple definitions of both oxidation and reduction reactions. Oxidation means the gain of electrons. Oxidation also means the loss of electrons, or we can define oxidation as loss of hydrogen. Reduction also defined as the loss of oxygen, the gain of electrons, and the gain of hydrogen. Oxidation and reduction reactions must occur together. Okay, there is no oxidation reaction alone. There is no reduction reaction alone. Okay, if one atom gives electron, another one must accept the electron. Okay, therefore, if one atom loses, the other one must gain. Okay, oxidation reduction reaction provides us with energy from food. For example, respiration is oxidation reduction, provides electrical energy in batteries, and occurs when iron rusts. Okay, what are the characteristics of oxidation and reduction reaction? Oxidation reaction always involve loss of electrons. Okay, loss of electrons. There is loss of electrons during oxidation reduction. Okay, oxidation reaction may involve addition of oxygen and loss of what? Hydrogen. Reduction reaction always involve gain of what? Electrons. This is a must. In reduction reaction, electrons must be gained. In oxidation reaction, electrons must be lost. In a reduction reaction may involve loss of oxygen and gain of what? Hydrogen. Okay. In an oxidation reduction reaction, electrons are transferred from one substance to another. Okay, this one is substance A, this one is substance B. Substance A loses electron, donates electron to what? Substance B is the acceptor one. Substance B gain, substance A loses electron. Okay, the process is oxidation. The process of losing electron is oxidation. The process of gaining electrons is what? Reduction. Okay, B gains electrons and changes to what? B minus, and A changes to what? A plus. Okay, this is reduction and oxidation reduction. Oxidation means loss of electrons. Reduction is gain of what? Electrons. Okay, how can we identify whether a chemical reaction is oxidation or reduction reaction? Okay, first you have to understand what does oxidation number and oxidation state mean. Okay, oxidation number or oxidation state is important to understand which reaction is oxidation and which one is reduction. Oxidation number is the number of electrons lost and gained during chemical reaction. Okay, the number of electrons lost or the number of electrons gained during chemical reaction is known as what? Oxidation number or oxidation state. There are regulations that we must follow to assign oxidation state. Okay, rules for assigning oxidation number. The first rule is the oxidation number of all elements in free states in neutral state is 0. Okay, this rule is also applied to diatomic and or polyatomic elements. The oxidation number of sodium is 0. The oxidation number of copper also is 0 because they are what? Neutral. Chlorine in Cl2 or chlorine molecule is 0. Oxygen in O3 is 0. Sulfur in S8 also is what? 0, and so on. Okay. The second rule, elements of group 1A have a positive 1 charge and elements of group 2A have a plus 2 oxidation state in all of their compounds. Okay, elements of group 1A are hydrogen, sodium, potassium, cesium, and so on. Okay, in their compounds, their oxidation state is positive. And group 2A, beryllium, magnesium, calcium, strontium, barium are group 2A. In their compounds, their oxidation state is positive. Okay. Rule number 3, the oxidation number of monoatomic ions is equal to the charge on the ion. For example, the oxidation number of Na plus is positive 1. The oxidation number of Na3 minus is minus 3. The oxidation number of magnesium 2 plus is positive 2. The oxidation number of aluminum 3 plus is plus 3. The oxidation number of calcium 2 plus is positive 2. The oxidation number of sulfur 2 minus is minus 2. Rule number 4, the oxidation number of hydrogen in its entire compounds is positive 1, except in metal hydrides like sodium hydride, calcium hydride, ammonium hydride, where its oxidation number is negative 1. Okay, when hydrogen is combined with metals, the oxidation number of hydrogen becomes negative 1 because hydrogen is more electronegative than metals. The oxidation number of hydrogen when it combined with non-metals is positive 1 because of electronegativity value of hydrogen is less than non-metals. Okay, the oxidation number of hydrogen either positive one or negative one. It can be positive one when it combined with non-metals. It can be negative one when it combined with what? Metals. Number 5, the oxidation number of oxygen in a compound in most compounds is negative 2, except in the following case. The oxidation number of oxygen in peroxides, for example, sodium peroxide, potassium peroxide, calcium peroxide, hydrogen peroxide is negative 1. Okay, the oxidation number of oxygen in superoxides, such as potassium superoxide, is negative half. The oxidation state of oxygen in fluorine, in difluoride, oxygen difluoride is positive 2, OF2. Okay, the only compound in which the oxidation state of oxygen is positive. Okay, because fluorine is the first most electronegative element, that's why it becomes what? Negative, and oxygen is the second one. That's why oxygen becomes what? Positive. Okay, rule number 6. The sum of the oxidation number of all the atoms in a neutral compound is 0. For example, H2SO4 is a neutral compound. The sum of the oxidation state of each atoms in sulfuric acid is equal to 0. First, identify the oxidation state of hydrogen, sulfur, and oxygen. The oxidation state of oxygen in most compounds is negative 2. The oxidation state of sulfur is positive 6. The oxidation state of hydrogen is positive 1. Okay, because hydrogen is combined with non-metals. Then add all oxidation states of each atoms in this compound. Okay, 2 multiplied by positive 1 is positive 2. 1 multiplied by positive 6 is positive 6, plus 4 times negative 2 is negative 8. When you add 2 plus 6 is 8, minus 8 is equal to what? 0. This implies the sum of the oxidation number of all the atoms in a neutral compound is 0. A neutral compound means a compound with no charge, or it is what? Chargeless. Rule number 7. In a polyatomic ion, the sum of the oxidation number of the constant atoms equals the charge on the ion. For example, this is SO4 minus 2, a polyatomic ion with a charge of what? Negative 2. The sum of the oxidation state of each atoms in these polyatomic ions is equal to what? Negative 2. Okay, the oxidation state of sulfur is positive 6. The oxidation state of oxygen is negative 2. 1 times positive 6 is 6. 4 times negative 2 is minus 8. Positive 6 plus negative 8 equals to minus 8, minus 2. This implies what? The sum of the oxidation state of each atom in polyatomic ions is equals to the charge on it. Rule number 8. In a compound, the more electronegative element is assigned a negative oxidation number, and the less electronegative element assigned a positive oxidation number. For example, the oxidation number of sodium and chlorine the oxidation number of sodium and chlorine in NaCl. Okay, sodium is less electronegative than chlorine. This implies the oxidation number of sodium is positive. The oxidation state of chlorine is negative because chlorine is more electronegative than sodium. Sodium is less electronegative, chlorine is more electronegative. Therefore, sodium has a positive charge, chlorine has a negative charge. Example, how can we assign oxidation number of atoms in a given compound? For example, what is the oxidation number of chromium in Na2Cr2O7? First, identify the oxidation number of sodium and oxygen. Sodium is group 1 metal. The group 1A metals or elements have a positive 1 charge. Oxygen in most compounds is negative 2. Okay, the oxidation number of oxygen is negative 2. Refer rule number 8. The oxidation number of sodium is positive 1. Refer rule number 2. Let the oxidation number of chromium be X. Okay, minus plus 1. The oxidation number of sodium and X, the required one, the oxidation number of chromium, and the oxidation number of oxygen is negative 2. Then Na2Cr2O7 is a neutral compound since the sum of the oxidation number of sodium, chromium, and oxygen in Na2Cr2O7 is 0. Okay, refer rule number 6. Then 2 multiplied by 1 plus x multiplied by 2, x multiplied by 2 plus 7 multiplied by negative 2. 1 multiplied by 2 is 2, x multiplied by 2 is 2x, 2 minus 2 multiplied by 7 is minus 4, minus 14. 2 plus 2x minus 14 equals to 0, and x equals to what? Positive 6. The oxidation number of chromium in Na2Cr2O7 is positive 6. Let's go to the next example, example number 2. What is the oxidation number of manganese in MnO4 minus? Okay, the oxidation state of MnO4 is minus 1, is polyatomic ion. Refer rule number 7. How can we find the oxidation number of Mn in MnO4 minus 1? Okay, this minus 1 is a common charge for manganese and oxygen in MnO4. Therefore, let's X is the oxidation number required and minus 2 is the oxidation number of oxygen. Then 1 times X is equals to X, 4 times negative 2 is equals to minus 8, which equals to minus 1, because the oxidation number of the sum of the oxidation number of each atoms in polyatomic ion is equals to the charge on it. This gives us what? X equals to positive 8. Therefore, the oxidation number of Mn in MnO4 is plus 7. Next, example number 3. Determine the oxidation number of phosphorus in CaH2PO4, common subscript number 2. Solution, the oxidation number of calcium is positive 2 because it is group 2A metal. Refer rule number 2. Let the oxidation number of phosphorus be X. Okay. Then Ca in the bracket H2PO4, close the bracket subscript number 2. Okay. This means CaH4, Ca in the bracket H2PO4, close the bracket 2 equals to CaH4P2O3. This is a neutral compound. This implies the sum of the oxidation state of each atoms in this compound equals to 0. We have a subscript 1 for calcium multiplied by 2 is positive 2. Hydrogen has subscript number 4 multiplied by positive 1 is plus 4. And phosphorus subscript number 2 multiplied by X is 2X. And oxygen has a -2 oxidation state, and subscript number 8, 8 minus 8 multiplied by -2 is -16. 2 plus 4 plus 2x minus 16 equals to 0. 2x minus 10 equals to 0, or x equals to +5. The oxidation number of phosphorus in calcium dihydrogen phosphate is +6. Okay, study check. Determine the oxidation number of the specified elements in each of the following. You can read at home. It's just like an assignment. Okay, study check number 2. Identify each of the following as oxidation or reduction. Is it oxidation or reduction? First, assign oxidation state for each atoms in the reactant and product side. Then you can identify the oxidation and reduction. If it is oxidation, oxidation number will increase when we go from reactant to product. Oxidation number will increase. For oxidation reaction, oxidation number will decrease from reactant when we go from reactant to product. If it is what reduction reaction. Okay, let's see the solution. Identify each of the following as oxidation or reduction. Sn converted into Sn plus 4 electron. This is oxidation reaction. Oxidation means loss of electrons. Okay, 4 electrons are lost from Sn. Okay, and the charge of Sn is changed from 0 to Sn4 plus. Sn is a neutral atom. The oxidation number of neutral atoms is 0. 0 change into what? 4 plus. This one is oxidation. The oxidation number of iron is decreased from +3 to +2, and because it gains what? 1 electron, and the process is known as what? Reduction. And the oxidation number of chlorine is changed to chlorine minus from 0 to -1 because chlorine gains electron. This one also is reduction. Next, what does oxidizing and reducing agents? An oxidizing agent, also called what? Oxidant, is the substance that causes another substance to get oxidized, but itself gets reduced. A reducing agent or reductant is the substance that causes another substance to get reduced, but itself oxidized. Oxidizing agents are substances that are reduced or gain electrons. Oxidizing agents are substances that contains elements whose oxidation number decreases. Reducing agents are substances that are oxidized or lose electrons and contain elements whose oxidation number increase. Example, identify the oxidizing agent, reducing agent, the substance oxidized and reduced in the following reaction. In this chemical reaction, identify the oxidized and reduced oxidizing agent and the reducing agents. Solution, let's assign oxidation number to all the elements of the reactants and products. Okay, first you have to assign oxidation number for each atoms in the reactant and product side. Hydrogen is combined with sulfur to give hydrogen sulfide. Sulfur is non-metal, therefore the oxidation state of hydrogen is +1. Okay, the oxidation state of sulfur is -2, and bromine is a neutral molecule, therefore it has a charge of 0, and the oxidation state of hydrogen in HBr is +1, and the oxidation state of bromine is -1. Because it is group 7, it gains what? 1 electron, and the oxidation state of sulfur becomes what? 0. Okay, the oxidation state of sulfur is changed from -2 to 0. This implies oxidation number increasing. Oxidation number is increasing from -2 to 0 because sulfur loses 2 electrons. Okay, reduction is loss of what? electron. Oxidation is gain of what? Electron. Okay, sulfur -2 change into what? 0. This is oxidation. And the oxidation state of bromine is changed from 0 to what? -1. This one is reduction. R2 is reduced. Sulfur in H2S is oxidized. In the process of converting sulfur -2 to S0 is oxidation. The process of converting bromine 0 to what? Br-1 is reduction. Therefore, oxidized substances are reducing agents. Oxidized substances are reducing agents. Reduced substances are oxidizing agents. Okay, let's see the solution. In the reaction, the sulfur atom in H2S increases its oxidation number from -2 to 0. Hence, S is oxidized and H2S is a reducing agent. The oxidation number of Br is decreased from 0 to -1. Thus, Br2 is reduced and is an oxidizing agent. Example number 2, write the oxidizing and reducing agents of the reaction given below. This is the chemical reaction. Write solution, write the oxidation number of each. You have to write the oxidation number of each atoms in the reactant and product side. The oxidation number of copper is 0 because it is neutral atom. The oxidation number of hydrogen is +1 because hydrogen is combined with non-metals, nitrogen and oxygen. And the oxidation number of nitrogen is +5. The oxidation number of oxygen is -2 because in most compounds, especially in polyatomic ions, the oxidation number of oxygen is -2. And copper in copper 2 nitrate, copper has a +2 charge, nitrogen has a +5 charge, oxygen - charge, nitrogen +2, oxygen is -2. And in H2O, the oxidation state of hydrogen is +1, the oxidation state of oxygen is -2. Okay, the oxidation state of hydrogen is changed from not changed. It's +1 in the reactant side, +1 in the product side. This implies hydrogen ion is a spectator ion. Okay, no change, no loss, no gain of what? Electron. Copper change into 0 to what? +2. Oxidation number increase. This means copper is oxidized. In the process of converting copper from 0 to copper 2+ is oxidation. Therefore, copper is oxidized substance and reducing agent. The oxidation state of nitrogen is changed from +5 to +2. This implies nitrogen in HNO3 is reduced, and it acts, HNO3 acts as oxidizing agent. Therefore, copper is a reducing agent and HNO3 is an oxidizing agent. State check. In light-sensitive sunglass, UV light initiates an oxidation-reduction reaction. Okay, 2Ag plus combined with 2Cl minus to give 2Ag plus Al2. Which reactant is oxidized? Which reactant is reduced? Okay, the oxidation state of silver is changed from +1 to 0. This one is 0. This one is +1. Okay, from +1 to 0. This is reduced substance. Ag plus is reduced substance, and the oxidation state of fluorine is changed from -1 to 0. This is oxidation. Cl minus is oxidized, and it acts as a reducing agent. Ag plus is reduced, and it acts as oxidizing agent. Okay. Okay. This is the answer for the study check exercise. Chlorine ion Cl minus is oxidized substance because the oxidation state of chlorine is increased from -1 to 0, and oxidized substances are reducing agent, and silver ion Ag plus is the reduced substance because its oxidation state is reduced, decreased. Concept check. Thermite is used to weld piece of metal together when electricity is not available as an energy source to melt iron. The thermite reaction produces molten through the following oxidation-reduction reaction. Okay, I will show you this chemical reaction, the thermite welding process, which is usually used in railway construction. Okay, aluminum reacted with Fe2O3 to produce Fe plus Al2O3. For the thermite reaction, identify the elements being oxidized and those being reduced. There are two ways to identify which substance is being oxidized and which is being reduced in the thermite reaction. This is the chemical reaction, a balanced chemical reaction. Aluminum is oxidized. Why? Because the oxidation state of aluminum is changed from 0 to what? +3. The oxidation state of aluminum in neutral form is 0. The oxidation state of aluminum in Al2O3 is +3. Oxidation number increased. This implies aluminum is oxidized because it gains oxygen. F is being reduced because it is losing oxygen. Okay, by the way, there are two ways of identifying which substance is oxidized and reduced. The first one, which one gain oxygen, which one lose oxygen. And the second way, which one gain electron, which one lose electron. Okay, in the first method, aluminum gains oxygen, iron loses oxygen. Okay, this oxygen atom is donated to aluminum. Aluminum gain oxygen, iron here in the product side stands alone. Okay, therefore we can identify the oxidized and reduced substance by gain and loss of what oxygen. In the second method, aluminum lost electrons and its oxidation number increased from 0 to 3 plus, and this is oxidized substance, and iron oxidation state decreased from 3 plus to what? 0. Therefore, Fe3 plus in Fe2O3 is reduced. Let me show you some common oxidizing agents. Oxidizing agents, antiseptics, and disinfectants are oxidizing agents because they oxidized or kill microorganisms. Here, antiseptic, Lysol, okay, all these are what? All these kind of chemicals are antiseptics, and disinfectants are what? Oxidizing agents. Oxygen, hydrogen peroxide, benzoyl peroxide, iodine, chlorine, sodium hypochlorite. This is the chemical that we use to treat water. Okay, sodium hypochlorite, usually commonly called what? Chlorine in tap water. Okay, all these are what? Oxidizing agents. Common reducing agents, less common in the household, more common on an industrial scale. Hydrogen, Haber process. Haber process is used for the manufacturing of ammonia. Hydrogen plus nitrogen gives ammonia. This is the Haber process in the presence of iron. Nitrogen fixation, elemental carbon, coke, reduction of metal ions. All these are reducing agents. They are not common in home, but industrially they are commonly used. In the following redox reaction, identify the oxidizing and reducing agents. Oxidizing agents are reduced substance, reducing agents are oxidized substances. Oxidized substance lose electrons, reduced substance gain electrons. Copper 2 plus reacted with zinc to give copper plus zinc 2 plus. The oxidation state of copper is decreased from 2 plus to 0 because copper 2 plus is reduced and it acts as oxidizing agent. And the oxidation state of zinc is changed from 0 to zinc 2 plus. This implies oxidation number is increased from 0 to 2 plus, and zinc metal acts as reducing agent because it is what oxidized. The oxidation state of magnesium is changed from 0 to what positive to NMnGO because magnesium is oxidized and it acts as a reducing agent because it helps oxygen to be what reduced. Oxidation state of oxygen is 0, changed from 0 to what -2. This implies oxidation number is decreased. This indicates O2 is reduced substance and it acts as oxidizing agent. It helps magnesium to be what oxidized. This is the answer for the concept check question. Okay, respiration and photosynthesis are redox reaction. In which animals, including humans, use respiration to oxidize food for energy. Okay, this is redox reaction. Photosynthesis also is redox reaction. Animals and plants depend on each other for life because plants use carbon dioxide and they release oxygen. Animals take this oxygen to oxidize glucose and produce carbon dioxide and water. Okay, carbon dioxide again used by plants. That's why animals and plants depend on each other for life. Okay, concept checked. What substance is the reducing agent in respiration? You can find it. From the concept check, this is a concept check solution. A reducing agent is a substance in a chemical reaction that is oxidized. The carbons in glucose lose hydrogen during respiration. If a substance loses hydrogen, it is what oxidation, and the substance itself is oxidized substance. The loss of hydrogen is characteristics of an oxidation. Therefore, glucose is oxidized, and it is the reducing agent in respiration. O2 is reduced, and it is the oxidizing agent. The second type of chemical reaction is non-redox reaction. As I said, when we start this lesson, chemical reactions can be classified into what two categories, redox and non-redox. In redox reaction, there is transfer of electrons from one substance to another. There is also reduction, loss of electrons, and oxidation gain of electrons. But in non-redox reaction, there is no loss and gain of electrons, only transfer of ions, exchange of ions between atoms. Okay, double displacement reaction, acid-base reaction are not oxidation reduction reactions. Say instead what? Non-redox reactions. For example, this is the reaction between barium chloride and sodium sulfate, the reaction between salts. Okay, produce barium sulfate and sodium chloride. Okay, barium oxidation state +2, barium in the product side oxidation state +2, no change in oxidation state. The oxidation state of fluorine in the reactant side is -1, and the oxidation state of fluorine in the product side is -1, no change in oxidation state. The oxidation state of sodium is +1 in the reactant side, +1 in the product side. The oxidation state of sulfur in the reactant side is +6, +6 in the product side, no change. Oxygen has a -2 charge in the reactant side, negative charge in the product side. No change in oxidation state. No, that means no loss, no gain of what? Electrons, but there is exchange of ions. Okay, barium replaces sodium, sodium also replaces barium. Okay, when barium replaces sodium, it forms barium sulfate. When sodium replaces barium, it forms what? Sodium chloride. Only exchange of ions. Okay, in non-redox reaction, there is no transfer of electrons, but there is exchange of positive and negatively charged ions. Okay, this is all about oxidation and reduction reaction. Uh, Thank you for watching. See you for the next time.